Hello everybody, in this video we're going to talk about how to find the minimum or the maximum value of a quadratic function. So for the quadratic function in standard form, f of x equals ax squared plus bx plus c, the y-coordinate of our vertex is the minimum value of the function if a is greater than 0, so that means our parabola opens up, so we have a minimum value, and or it's the maximum value when a is less than 0. So if a is a negative number, our parabola is going to open down, so our vertex is going to be at the top, that'll be our maximum. So on the left side of our screen here, we see when we have a parabola that's opening up or when a is greater than 0. So notice how we have a minimum value down here. So there's a couple properties about our graph that we can interpret or identify. So first of all, the minimum value would be the f of opposite of b over 2a. So if you remember opposite of b over 2a, that's the equation for the axis of symmetry. And our axis of symmetry is our imaginary vertical line that goes right through our vertex. So it's going to have the same x-coordinate of our vertex. So to find the maximum or the minimum, we can start off by finding the axis of symmetry, so x equals opposite of b over 2a. And once we have that number, we can find the f of that number, which means just take that value for x, plug it back into your equation to solve for y. And that y value is going to be your minimum or your maximum. So for both of these, our domain is going to be all real numbers because we're dealing with a parabola that opens up or down. So it's going to open up and slightly out on each of these examples. Our range is going to be y is greater than or equal or less than or equal, depending on if we're talking about a maximum or a minimum, and whatever the number for the minimum or the maximum is. Okay. If our parabola is opening up, then we can talk about the parabola decreasing to the left of our axis of symmetry and increasing to the right of our axis. And if our parabola opens down like we see on the right side of our screen, we're going to increase on the left side of our axis of symmetry and then decrease on the right side. Okay, so let's look at an example here. It's actually two examples in one. And it says find the minimum or maximum value of f of x equals 4x squared plus 16x minus 3 and h of x equals negative x squared plus 5x plus 9. Describe the domain and the range of each function and then where each function would be increasing and decreasing. So we're going to start off with our f of x function here, and it is 4x squared plus 16x minus 3. So I'm going to write it right here, 4x squared plus 16x minus 3. So the first thing I notice here is that a is positive. Okay, so now if I were to just kind of draw this here, my parabola is going to open up, which means we are going to have a minimum. Okay, we're going to have a minimum. I know that because a is 4 and that's a positive number. Okay, so now we're going to go ahead and find our axis of symmetry. So we're going to say x is equal to opposite of b over 2a. Well, b is 16, so the opposite of that would be negative 16, and then 2 times 4. So we get negative 16 over 8, which is negative 2. So now that we have x is equal to negative 2, we know that that is our axis of symmetry. So x equals negative 2. And we'll just put a box around that. That's our axis of symmetry. And that's going to tell us where our graph is increasing or decreasing. So we'll come back to that in just a second. Now we want to find our actual minimum value. So we're going to take negative 2 and we're going to plug it in for these x values right here. Okay, so we'll do it right here. 4 times negative 2 squared plus 16 times negative 2 minus 3. So this is 4 times 4 minus 32 minus 3. So we have 16 minus 32 minus 3. And when we do that math, we're going to get negative 19. So our minimum value is negative 19. So our domain here is all real numbers. That's our all real numbers sign. Our range now is going to be y is greater than or equal to negative 19. Greater than or equal because it's our minimum point, so all other y values higher than negative 19, and also including negative 19, but no lower than that. And so now if we go back to our axis of symmetry, we would say that our graph is decreasing to the left of x equals negative 2 and increasing to the right of x equals negative 2. Okay? All right, let's switch up our color here and let's go with our h of x function now. So we'll write it right here. We have negative x squared plus 5x plus 9. Okay, so now I notice here that a is negative, so our parabola now is going to open down, so something like this. And now we are going to have a maximum. Okay, so here's our maximum example. Now let's go ahead, just like the minimum example, let's find our axis of symmetry. So we're going to say x is equal to opposite of b over 2a. In this case, b is 5, so now we have negative 5 over 2 times negative 1, which would be negative 5 over negative 2, which we can write as 2.5. So now we have x equals 2.5, and that is our axis of symmetry. So now we're going to use that, plug that back into our original equation to solve for y, and that's going to be our minimum value, or excuse me, maximum in this case. So now we have negative, and then 2.5 squared plus 5 times 2.5, and then plus 9. So 2.5 squared, that's going to give us 6.25, and then we're going to make it negative. 5 times 2.5 will give us 12.5, and then we add 9. So we do the math on this, and we're going to get 15.25, and that would be our maximum value. So now we can say, once again, our domain is going to be all real numbers, but now this time our range is going to be y is less than or equal to 15.25. Less than or equal because our parabola is opening down, so our maximum point there is 15.25. So now in terms of increasing and decreasing, so now to the left of 2.5, our parabola is going to increase, and to the right it is going to decrease. Okay, so that's how you can find the minimum or the maximum of a quadratic function.